Welcome back. This is Mrs. RRubright and we're Advanced Geometry. Today's notes are on 8.4, Properties of Rhombuses, Rectangles, and Squares. We already started by copying the notes from the textbook on page 527 and 529. For any rhombus, QRST, decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So we were going to sketch out rhombus, QRST. So we have our quadrilateral QRST, and we want to decide whether the statement is always or sometimes true. So angle Q is congruent to angle S. Well, for any rhombus, if this is a rhombus has all equal sides. A rhombus is a crooked square, all equal sides, and it has opposite angles are congruent. So this will always be true if it's a rhombus. So by theorem 8.4, opposite angles of a parallelogram are congruent. So angle Q is congruent to angle S. The statement is always true. How about angle Q and angle R? Q, R, S, T. If this is a rhombus, all equal sides, opposite angles are congruent. Will angle Q be congruent to angle R if it's a rhombus? Always, sometimes, or never? Sometimes. Only if that rhombus is a square. A square is a special type of rhombus with all right angles. So if the rhombus is a square, then yes. So this is sometimes true. Because a rhombus is a square, but a square is not necessarily, a square is always a rhombus, but a rhombus is not necessarily a square. Kind of like a square is a rectangle, but a rectangle is not necessarily a square. Because a square is a special type of rectangle that has all equal sides. All right, so you have to kind of think about well, what is a rhombus? Opposite sides are congruent, all sides are congruent, opposite angles are congruent. The only difference between a rhombus and a square is that the square has all right angles. Okay, so this would be sometimes true. You have to be really careful with these. Classify the special quadrilateral, explain your reasoning. All equal sides, and this is 70. So what would this thing be called? A rhombus. Look at this. If I went like this, this line is congruent to itself, reflexive. So by side, 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 these two triangles are congruent to each other, right? So this is 70, this is 70. Corresponding parts of congruent triangles are congruent. These are isosceles, so the base two angles are equal. 180 minus 70 is 110, making this 55 and 55. These would also be isosceles triangles, right? 110 plus 110 plus 70 plus 70 equals the 360 that a quadrilateral should add to. See how this all works together? This thing is totally a rhombus. The quadrilateral has four congruent sides. One of the angles is not a right angle, so the rhombus is not also a square. By the rhombus corollary, the quadrilateral is a rhombus. For any rectangle EFGH, why don't we just turn this box into an EFGH? EFGH. Is it always or sometimes true that FG is congruent to GH? FG is congruent to GH. What do y'all think? Always, sometimes, or never? It is sometimes. It is only if this is a square. Because opposite sides are equal. So if these two are equal, well then this whole thing, all sides are equal, therefore it is a square. So the rectangle would be a square. Sometimes. Only true if it's a square. A quadrilateral has four congruent sides and four congruent angles. All equal sides, all equal angles. If all the angles are equal and it's a quadrilateral, 360 divided by 4 is 90 each. What shape is this? It is a square. Sketch a rectangle ABCD and list everything that you know about it. So if we have rectangle ABCD, what do we know? Opposite sides are equal. Opposite sides are parallel. All right angles. What else? Opposite angles are congruent. By definition, you need to draw the figure with the following properties. The figure is a parallelogram. It has 4 right angles. It also, because it's a parallelogram, it has the following properties. Opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive interior angles are supplementary. The diagonals bisect each other. By theorem 8.13, the diagonals of triangle ABCD are congruent. Sketch square PQRS and list everything that you know about the square. So if we drew a square PQRS, what do we know? We know that all angles are 90 degrees. We know that opposite sides are congruent and parallel. We know that all sides are congruent. We know that opposite angles are congruent. We know that the diagonals do what? Bisect each other, right? So we know that it's a parallelogram, a rectangle, and a rhombus. We know opposite pairs of sides are parallel and all 4 sides are congruent. All 4 angles are right angles. Diagonals are congruent and bisect each other. You are building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Given the measurements in the diagram, can you assume that it is? Explain. Opposite sides are equal. Because opposite sides are equal, is it a rectangle? No. We need to know that the opposite sides are congruent and parallel. Because couldn't it be a parallelogram where it's like slanted? Like a rhombus is slanted, right? You would have to measure the diagonals. They measured the diagonals. They have 54.8 and 55.3. So if the diagonals are not congruent, then it is not a rectangle. This was the issue that I had when I had my hurricane windows and doors installed. When they're installing a window, the glass of the window keeps it completely straight. You can't have any swaying left, right, up and down, because the window, the actual glass, keeps the frame solid. If you are installing a door and they're only installing the frame, they don't have the glass or the door in the frame when they install it, it can go front to back. It can go left and right. So you have a lot of wiggle room that can go wrong. So when my doors wouldn't close and they were like, oh no, that's how it's supposed to be. I'm like, no, they're supposed to lock and they're supposed to close without me having to manhandle them. I looked it up on the internet and it's called hinge binding. And I was like, well, it's having some hinge binding. And it's because it's not in perfectly. And they were like not understanding what I was saying, even though I was speaking their language. So then I started speaking geometry. And I explained to them that unless these corners are at 90 degrees, then it's not going to work. Your diagonals have to be equal. So they could put a diagonal support in while they're installing and it would make their lives a lot easier. But if you just put up a little triangle into each corner, if it's not at exactly 90 degrees, your doors will not close properly. So I made them uninstall and reinstall. So, by theorem 8.13, the diagonals of the rectangle must be congruent for it to be a rectangle. Suppose you only measure the diagonals of the window opening. If the diagonals have the same measure, can you conclude that the opening is a rectangle? Yes, theorem 8.13. And that is today's lesson on 8.4, properties of rhombuses, rectangles, and squares. We hope you enjoyed the lesson. Have a great day and subscribe to our channel.